Right, okay, so now we're moving on to question 3. And, well, I'm just sorry that I keep having to restart this video. It's driving me nuts. I need to improve my editing skills. Anyway, here we are. We're on the June 2016 S1 paper, IAL. And we're on to question 3. And this is about the 4th video that I've downloaded for this. I'm really sorry. Or uploaded? I don't know, whatever. Right, okay, so we're looking at these nice probability distributions, so it's nice and easy work. And then the probability of us ever having the x is 1/5. So it's 1/5 for all of these. And that's a nice, uniform, discrete distribution. Okay, so that is the answer to that first question, which is nice and easy. So I'm going to write that here, I have enough room. So it's discrete, uniform distribution. I've gone here, but you're never going to write there because that's naughty. So that's 1 mark. Thank you. Find the probability x equals 4. Okay. Well, in actual fact, x equaling 4 is 1/5. So the answer to that is 1/5. X being 4 is 1/5. Do you know, at this point, I'm now going to do the table just here, because I know they're going to ask me loads and loads of questions about this, and I just think it's easier to get the table over and done with. Alright, so x is 1, 2, 3, 4, oops, 5. Squeeze that 1 in there. Okay, and probability of x equaling x. So for 1 it's 1/5, because it's saying that each of these is 1/5, 1/5, 1/5, 1/5. Now, as soon as they start saying f of 3, we know that this is like continuous. So I'm now going to do that here. F of x equaling x. So I'm now going to do my cumulative. So here we go. So 1 is 1/5, and now this is this, add this, and that's 2/5. That, add that, 3/5. This, add this, 4/5. This, add this, 5/5, which is the same as 1. We should always end up with 1 at the end of this. Okay, so now f of 3, cumulative, being 3 is up to this point, so that's 3/5. Okay, now we start to get a bit trickier. Okay, so looking at part D, a bit trickier here. So we've got to solve this equation first. So I've got 3x minus 3 is larger than x plus 4. So now I'm going to take the x over here, take it away, and I'm going to take this over here and add. Alright, so 3x, take away x is going to be 2x over here. When is 2x bigger than 4? Add 3, so that's 7. And so x needs to be bigger than 3.5. Okay, when is x bigger than 3.5? Well, here and here, 4 and 5. Alright, so that answer then is 2/5. Okay, write down the expected value of x. Oh, I should have left more space here. So here we go. Expected value of x. This is when I multiply them. 1 times 1/5 is 1/5. 2 times 5 is 2/5. So it's going to be the same again. 3/5, 4/5, 5/5, which is 1. Add them all together. So that's going to be 3. The expected value is 3. Does that kind of look right? Yeah, it does, because we could take the value of 1 to 5, and it's uniform, so it's symmetrical. So basically, I didn't even need to work it out. Oh, 1 mark, look at that, I've just spotted it. Only 1 mark. So there you go. Right, so moving down. Expected x squared is going to be 1 squared times 1/5 See, I knew I should have left more space here. So we've got is 1 squared times 1/5 plus 2 squared times 1/5 plus 3 squared times 1/5 plus 4 squared times 1/5 plus 5 squared times 1/5. Okay, so that equals 1/5 plus 4/5 plus 9/5 plus 16/5 plus 25/5, which is 10, 20, 30, 55 over 5, which is 11. Okay. The variation of x. Okay, well there's quite a big clue here because we've just worked out the expected value of x squared, and it says hence. So it says basically from what you've just found out, now find this, and we know the variation of x is this formula, e of x squared minus e of x squared. So this equals, okay, e of x squared is 11. Take away this 3 squared, which is 9, so that's going to be 2. Okay, the variance is 2. Okay, and now we're finally moving on to the last part. Okay, and so for the guys I'm teaching this year, that's for the 2020 exam, I wouldn't worry about this question because we've said about leaving the variances out. But anyway, I'm going to just quickly work through it for those of you that want to be getting your A's. Okay, so we've got here, given that e of, ignore this part for now, so we're going to look at this, e a of x minus 3 equals 11.4. So I'm going to take this out here, so we're going to go minus 3 plus a times the e of x equals 11.4, and so that's minus 3 plus a, well the e of x we've found out already back here somewhere is 3, equals 11.4. So let's get that minus 3 over there. So we've got 3a equals 14.4. So a therefore must equal 4.8, I believe, that divided by 3. Let's just check that. 14.4 divided by 3 is 4.8. Yeah, that's cool. Alright, so now we know what a is. So now we're going to answer the question, alright? So I've solved this for a. Now we're going to go back to the variation. I'm just going to move this up a bit. Okay. There we go. So for the variation, the variance of a of x minus 3, we're going to go, well this equals, and so we've got a comes out and we square it, 4.8 squared, and then we're going to times that by 2 because we've got here the variance of x up here was 2. So we're going to times that by 2, and that gives me, and we don't need to worry about the minus 3 because that's just moving things up and down. So that gives me 46.08 for those last 4 marks. But that's, you know, the variance is always the tough ones on these questions. Okay, so we're moving on to question 4, and this is a bit of continuous data here. So it says it's all about the information, which is the time people spent on the mobile phones for each child in a club. Alright, and the researcher, sorry you can't read this bit, the researcher coded the data using this, and I would imagine at some point we're going to need to come back to that. Well, they wouldn't tell us otherwise, would they? So V, the coded time, that's been used for coded time, but it's the time in minutes. Okay, so before we start, let's just check to make sure there's no gaps here, and there aren't, so that's good. So we know that these are, we don't need to do anything with that, we can just leave it how it is. Let's have a look at the first question. Okay, write down the value of A and B. Oh, and they've also given us this stuff here, so that's good. Right, A and B. So here's A. What have they given us here? This is a coded time midpoint. Okay, so this is a midpoint of each thing. So we know the middle of this, 5 divided by 2 is 2.5. So we've got here frequency. Well, we don't need to know the frequency, so we just need to do 10 add 5, 15 divided by 2. So A is going to be 7.5. And then B is down here, so 20 add 30, that's 50 divided by 2, so that's going to be 25. Just have a quick check, see if that looks, yeah, that's easy, 1 mark. Okay, oh, only 1. Right, estimated value, sorry, an estimate for the mean. Okay, so we know the mean, we have to add everything up together and divide it by how many there are. What is the frequency here? How many people were there included in this? That's 10, 14, 22, 6, 80 people, 80 children in this survey. Okay, so we know we're going to divide it by 80. We need to remember that to calculate this, we do the midpoint times the frequency. 20 people, don't know how much, but it's somewhere in there. So we're going to do 20 times 2.5, and I'm going to add another column here. Okay. FM. Right, 20 times 2.5. 10 is 25, so that would be 50. 24 times 7.5. I'm going to have to use my calculator, definitely getting brain drain here. Times 7.5 is 180. 16 times 12.5, 200. 14 times 17.5, 245. And lastly, 6 times 25, that's going to be 150. Right, so that's how much there is in each group. Now we need to add all this together. So we're going off the page. We're going 50 plus 180 plus 200 plus 245 plus 150 equals 825. So that's the total amount of time the kids spent on their mobile phones, and there are 80 children, so we're going to do 825 divided by 80 is wow, 10 minutes, 10.3125 minutes per child on their mobile phone. Wow. Well, I hope they were there for longer than half an hour, otherwise it's a waste of money, isn't it? Right, so that's the mean for V is 10.3125 minutes. Okay, that's another mark. So now we're going to go on to the standard deviation. Okay, we know that the standard deviation is the variance is the square root of the variance, so the variance is the sum of fm squared divided by the sum of f minus sum of fm divided by sum of f, which is basically the mean, squared. Okay, so here we go. Sum of fm squared, they've given that to us at the top here, look. Sum of fm squared. So that's 1, 2, 012.5 divided by, there were 80, yeah, take away, we worked out this here is actually, well, the average is 10.3125 squared equals 12012.5 divided by 80 minus 10.3125 squared is 43.8 blah 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 43.8 blah 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 blah, and we need the square root of that. Square root of this is 6. Oh my word, these numbers go on forever. 6.6188, going on and on and on. Right, so that's the standard deviation. Just gonna get that to stand out a bit. Okay, standard deviation 6.619 roughly. Right, use linear interpolation to estimate the median. We know as soon as we see the words linear interpolation, we must do this, and we need to find halfway. There are 80 children altogether, divided by 2. So we're looking for the 40th child. Right, let's go back up to the top and add another column here to make that our cumulative frequency. So that's 20, 44, 60. Well, actually, we're looking for the 40th. We can stop there. We know the 40th one is going to be in this group here. So we've got all the information we need in that group. That's where the 40th one is going to be. Okay, so the 40th one is between 5 and 10 minutes, and we know that it starts with the 20th person, it finishes with the 44th, and we want the 40th person, so it's going to be right up here, it's going to be right up high. Okay, so we're going to start with a 5, we do 5 plus bracket, and the distance between here and here is 20 divided by, oh, it's 24 altogether, the width of that, and then times by the actual width of the group, which is 5, equals, here we go, 5 plus bracket 20 over 24 times, times 5 bracket equals 9 1/6. Strange. Yep, 9 1/6. Is it easy to keep it like that? Or we could say 9.16 recurring. Yeah, okay. So that's the median. Is that looking about right? Is that looking about right, the median? 9.1, yeah, because that's in that group there. It's quite close to the 10. So that's about right. Okay, so here we go. Now they're asking us to compare or to describe the skewness, and we know that to do that we have got to compare the mean and the median. So let's have a look what's happened here. So the mean is 10.3125, and it's bigger than the median, which is 9.16 recurring. So if I was going to do that like this, I'd have my thing going like here, with a median would be about here at 9.16 recurring, and the mean is here at 10.3125. And so because this is going like this, it's a positive skew. Positive skew. Okay, and we've said everything we need to in that to get 2 marks. Okay. So let's have a look at the last question then to give us 4 marks. Gosh, So is that going to be quite hard? Yeah, I've got a feeling we might be going back to the coding now. Calculate estimates of the mean and the standard deviation of the time spent using a mobile phone during the afternoon by children in this class, because everything so far has been on the coded data, and now we're going to need to go back to the original data to get these last 4 marks. Okay, so going back to our coding, which is up here, we've got v equals t minus 5 divided by 10. I'm going to write that down here at the bottom. So they told us that v equals t minus 5 divided by 10. Okay, so for the mean, everything's going to be affected here. The dividing by 10 and the taking away the 5 is going to affect the mean. Okay, all of that affects the mean. So at the moment, the mean is 10.3125. So let's see what happens if we now put all of this back into here. So we're going to times that by 10, and then we're going to add the 5. All right, so when we do that, it equals 10.3125 times by the 10 plus the 5. It's 108.125. So it's 108.125. Okay, that's taken our coding right the way back. Okay, so that is, gosh, the average time the children spent on their phones in the club. Oh, that's nearly 2 hours. In the afternoon, so it's just in a few hours. Oh my goodness. Right, okay. Anyway, I mustn't get upset by this. And moving on, so the variance, the standard deviation, is not going to be affected by the minus 5, because all that's going to do is just move the data up and down. But it is going to be affected by the 10. So at the moment, the standard deviation was, I'm looking back, it was 6.619, say. Okay. We don't need to worry about the minus 5, but we do need to concern ourselves with 10. So we're going to times that by the 10, and that gave us a standard deviation of 66.19 minutes. Seems like crazy data to me. Okay, and that's the end of question 4. 4, 6, 8, 10 marks. Okay, wasn't as many marks as question 1, which was so much easier. And now we are going on to question number 5. Oh, we've already had one of these questions on this paper. That's crazy. So they've done 2 of these questions. Very odd. Okay. Okay, question 5. Right, so we've got a dice that's been rolled and it's biased. And we can see it's biased here. It's really clear because it's got the numbers 0, 1, 2 and 3, and these have all got the same probability, but to roll a 3 is a probability of a half. So it's clearly biased dice. Getting a bit tired. And the number is recorded. Okay. And now it says, if x equals 3, then the final score given is 3. But if it doesn't equal 3, then the dice is rolled again, and the final score is a sum of the 2 numbers. So, for example, if I roll a 0 and then I roll a 1, I get a final score of 1. Okay. Right. So this looks like it's going to be more about probabilities than the table. Let's have a look. So first of all, find the probability that t, which is the final score, so we're finding the probability that the final score, I'm going to move this up a bit, is 2. So A, the probability that the final score equals 2. So we need to think about what outcomes we have. Okay, so we're going to say, right, so the way this could happen is I could roll a 0 and then I need to roll a 2. So I need that to happen. Or I could roll, there's no other choices with a 0 because I want the answer to equal 2. I can't do a 0 and a 1 because that would add up to 1. I can't do a 0 and a 3 because that would add up to 3. And so 0, 2. The other option is I could throw a 1 and then another 1 the second time. That would give me a score of 2. Or finally, I could roll a 2 the first time and 0 the second time. Alright, so I've only got 3 different combinations. So let's write down the probabilities. The probability of rolling a 0 is 1/6. And I've got to have this happen as well. So that's times, and the probability of a 2 is 1/6. And if I have an OR here, I'm going to add. And then 1 and a 1 is 1/6 times 1/6 again. And then I've got an OR, that's an add. Let's pop these in brackets. And then finally, to roll a 2 is 1/6. And to roll a 0 is the probability of 1/6 again. Okay, let's add these up then. So that equals 1/36 plus 1/36 plus 1/36. So altogether that's 3/36, which is the same as 1/12. So that's part A. Okay, let's move on to B. B says find the probability that t equals 3. So now we've got the probability that the total score is 3. Okay, so how can I do that? Well, I could roll a 3 to start off with, and then that's the end of the game. So I could roll a 3, or I could do a 0 first and then a 3, or I could roll a 1 and then a 2. Are there any more? Oh yes, or I could roll a 2 first and then a 1. And these are the only, well, there are 4 ways of me getting a 3. So the first one, the probability of me rolling a 3 the first time is a half. The probability of me doing a 0 and then a 3, oh hang on, there's an OR there, so it's a plus. 0 is 1/6 and 3 is 1/2 times. Then a plus here, and then I've got probability of a 1 is 1/6 and the 2 is 1/6 plus, because it's OR, and then finally 1/6 times 1/6 again. Okay. Right, don't forget when I say I could have a 0 and a 3. 0 and a 3 is the AND rule where we always multiply. Okay, so that's 1/12 plus 1/2 plus 1/12 plus 1/36 plus another 1/36. That gives me all together, if I add all those up, I have 23/36. Okay, we can't cancel that down. 23 is a nice prime number. Right, oh, went off the page. Sorry. Okay, then finally part C. So we've got 5 marks so far, right? So part C is, given that the dice is rolled twice, so given it's rolled twice, find the probability that the final score is 3. I need to write this down. So I'm finding the probability that the final score is 3 given that it's rolled twice. The only way it can be rolled twice is if we don't get 3 the first time. Alright, so I need to write this down here. Given that it's rolled twice, it's going to go at the bottom. If it's rolled twice, it means the first time it wasn't a 3, and so if it wasn't a 3 the first time, it's going to be these 3 added together, which is a half. Okay, so that's going to go on the bottom. Okay, it's going to be divided by half. So probability it could be a 3 is, I've already worked that out here, haven't I? No, I haven't. Okay, because that included, if we look here, I've sort of worked it out, because given that it's 3, and it's got to be rolled twice. Well, that's going to get rid of that bit because it was only rolled once. But here we've got all of the ones where it is rolled twice. Okay, so basically I need to add these together. 1 over 12, well that's the same as 3 over 36. Add 1 over 36, add another 1 over 36, so that gives me 5 out of 36. So that's going to go here, that's my top part of my fraction, 5 out of 36. So let me do that in black because it's not coming out very well in the video. 5 out of 36 divided by 1 over 1/2, and that's going to be 5 over 18. Okay, so that's the final 3 marks. So all of this question's a bit, well, you've got to like probability, I think, to answer probability questions. So that's question 5. Hopefully we're near the end now. Question 6. How many questions on this paper? Oh, and there's a 7 as well. Okay, so it's going on and on. Oh, and now we've got another probability question. Right, okay, let's have a look at this. Okay, let's have a little look at this. Question 6. So we've got 3 events, A, B and C, are such that probability of A is 2/5, C is 1/2, A union B is 5/8. And given that A and C are mutually exclusive, find the probability of A union C. Right, so this is interesting because they're mutually exclusive, they can't happen at the same time, and we want to find A union C. So if I was going to draw this, which I think it helps to draw it, I've got A here, I've got B here, and I've got C here. Ooh, it's a bit squashed and Mickey Mouse looking. And it says that A and C can't happen at the same time. So that means that I have nothing in this part here. That's completely empty. There can't be anything there because they're mutually exclusive. So basically A here, this and this is 2/5 altogether. So that's 2/5 for the whole thing. And C is 1/2. So all of this is 1/2. All of this. So if I want all of that and all of that, because there's no overlap, I can just do 2/5 add 1/2 equals, what does that equal? 2/5 add 1/2. That equals 9/10. Okay, and that's the answer to that part. Right, now given that A and B are independent, show the probability of B happening is 3/8. I always like when they give us the answers because then we know if we're right when we've worked it all out. So A and B are independent. The probability that B is 3/8. Let's think about this. Okay, so we need to remember our rule that when things are independent, the probability of A intersection B is the same as the probability of A times the probability of B. Okay, probability of A is 2/5, and we've got A union B. All of A and all of B is 5/8. Right, okay, looking at this, it's not going to help. We're not going to be able to use that. So we're going to have to go to our tables and use this one here, which tells us probability of A union B is the probability of B plus the probability of A, take away a probability of A intersection B. We're going to have to use this from our formula books. So I'm just going to write that down as our rule here. So this is B, carrying on down here, B. Okay, so I'm going to use the rule from our formula sheet that says probability of A union B equals probability of A plus the probability of B minus the probability of A intersection B. Okay, right, that done, here we go. So we're going to go A union B. They've given us at the top here is 5/8. Okay, so I'm just going to whop that there. So we know that 5/8 equals probability of A is 2/5. We know that from here, from the top. Plus probability of B, we don't know, that's what we're trying to prove. Minus probability of A intersection B, which is A, probability of A, which is 2/5 times the probability of B. Okay, so that's 5/8 equals 2/5 plus the probability of B minus here we go, minus plus the probability of B, I was trying to take a shortcut there, minus the probability of 2/5 of B. Probability of 2/5 of B. It's a bit messy, I don't really like my notation here. Right, so we're going to take this over here, 5/8, take away 2/5, let's just work that out. 5/8 minus 2/5 is 9/40. So 9/40 equals probability B, take away 2/5 of probability B, so that's 3/5 probability of B. So now divide by 3, 9/40 divided by 3/5 equals 3/8. Yes, thank you very much. 3/8 equals the probability of B, which is what we had to prove. Back here it said, show that the probability of B equals 3/8, and there we have shown it, and that's 4 marks. That's a bit of a steamer, I think. Certainly got my brain going. And so then for part C, find the probability of A given B. Okay, so this equals the probability of A intersecting B over the probability of B. So that equals, have we done the probability of A intersection B? No, we haven't yet. So that's so it's the probability of A, which is 2/5, times the probability of B, which we've now got, and is 3/8, all divided by 3/8, and that gives me the answer of 2/5 times 3/8 divided by 3/8 equals 2/5. 2/5. Okay. And so then finally, moving on. Okay, D is a little bit, it takes a bit of working out. Again, do I keep saying that? I don't know. So we're told that the probability of it not being C, intersecting with not being B, is 0.3. Okay, so not in C, not in B is 0.3. And we know that means that if I draw a little sketch here, okay, and that's A, B and C, and don't forget we've got the outside here as well. So here we know that this bit in the middle here is 3/20, A and B, and that this part here is 1/4. So basically we know that 1/4 plus the outside part, the things that aren't in B or C, adds up to 0.3. So we know that this part here on the outside is 0.05, because 1/4 add 0.05 makes 0.3, because that's 0.25. Okay, so we wanted everything that wasn't in B and C, so everything that's not in B and C is this part here and the outside. So now we know the outside bit is 0.3. And I think, yeah, the question wants us now to draw a proper Venn diagram. So let me get on and do this, because that's rubbish what I've been drawing so far. So here we go. A, B, C, inside a box, and it's very untidy. A, B, C. And I know I'm going to use a blue pen here. I know that this part here on the outside is 0.05. Okay, and we know this part for A is 1/4. And what else do we know? We know that A intersection B is 2/5 times 3/8. So let's see what that is. 2/5 times 3/8 is 3/20. So I know the bit here is 3/20. We know that this bit here is empty from part A because they're mutually exclusive. Right, so now the difficult bit we're going to work out here is, because we know that all of C, we know the probability of C is 1/2, and we also know the probability of B is 3/8. Okay. Right, so let's see what this area here is going to equal. I'm going to call this X. Okay. So I know that the probability of all of this, C, is 1/2, and the probability of all of B is 3/8, and they're going to overlap here. So I'm going to call that, we need to take away, because that will be added in twice, so we need to take that away, and then that's going to equal 1 take away all of the other things added together. So we've got 1/4 plus 3/20 plus 0.05. Okay, so this plus this plus this, take away that because it's overlapped, is going to equal everything, take away the 3 bits we already know. Okay, so here we go. 1/2 add 3/8. Let's do this. 1/2 plus 3/8 is 7/8. 7/8. 7/8 take away X equals, kind of doesn't feel right to me, but anyway, 1 minus bracket, sorry, done that. 1 minus bracket 1/4 plus 3/20 plus 0.05 equals 0.55. Okay. Right. I knew that this just kind of doesn't feel right, and that's here I've made a big mistake, because that's wrong, because the probability of B is 3/8, but of course I've already used up 3/20 here in the overlap with A, and I need to get rid of that. So, stupid me. 3/8 minus the 3/20, I believe it is. Minus 3/20 is 9/40. This here should have been 9/40. So that's my big mistake. Right, so 1/2 plus 9 over 40 is 29 over 40. 29 over 40 minus x equals 0.55. Right, let's have a look at this. So 0.55 minus 29 over 40 gives me minus x equals minus 0.175. So x therefore equals 0.175. Okay, do you know what? I'm going to change that into fraction because I don't like all of these decimals. So that's 7 over 40. So that's what the x bit is. This bit here is 7 over 40. Oh, it's so messy. Now we can work out what c is, because c was a half. So we've got 1/2 minus 7 over 40 equals 13 over 40. That goes there. And then for b, we had for b 3/8 minus 3 minus 3 over 20 minus 7 over 40 equals 1/20th. So that goes there. Okay, then if we add all these together, please, please, please let them equal 1. So let's go for this. 1 over 4 plus 3 over 20 plus 1 over 20 plus 7 over 40 plus 13 over 40 plus 0.05. Please equal 1. Oh, it does. Yay. Right. Oh, that wasn't many marks either. That's 5, 10, 11 marks for that question. That was really horrible. And we have one question left, and it's going to be normal distribution with probability again. Gosh, when I wrote this paper, really liked probability questions. Well, of course it's going to be probability because it's normal distribution. Right, okay, so on with this. Okay, final question, number 7, and you've got a normal distribution, and I'm going to need to do this on a separate piece of paper because it's quite, we have to do our drawings and everything. So here we go. So for part A, we're going to do, here's the distribution. It is that the average is 503 and the standard deviation is 1.6. Okay. So for A, part 1, we're doing the probability that x is bigger than 505. So what is this? Volume of water. Okay. So here's our drawing, and that's Z along the bottom. And the mean goes here, so that's 503, it's there in the middle, and we're looking at it being 505, but we want it to be bigger than 5, so we're looking at this area here. Okay, looks quite straightforward. So we're going to go Z equals, x minus mu over standard deviation. So that's going to be x is 505, take away the average, divided by 1.6, and that is 2 divided by 1.6, which is 2 divided by 1.6 is 1.25. Right, so that's my Z value, don't forget, 1.25. So now we need to go to our tables to look up the probability. So Z values start here. Z value is here. So we're going down until we get to 1.25, which is here. 0.8944. 0.8944. So that is the area, don't forget. So the area here is 0.8944. We just want to know this area here. So we do 1 take away 0.8944, which gives me 0.1056. So that's the answer to part 1. Okay, that's nice and easy. Moving on to part 2, it's probability that we have a value between 501 and 505. So let's have a look at that. Part 2 is the probability it's between 501 505. Well, I've already done the 505, so now let's have a look at the 501. In actual fact, can I just reflect this over here? I can, can't I? Because that's a space of 2 there and it's a space of 2 there. So I think we might have already worked out a load of this. That's Z. 503, 501, and we know that this over here was 1.25, that's minus 1.25, and we know that the area here is 0.1056. We know that because that's what it was there, it's just reflected over. So that's that there. And at 505 over here it was 0.1056. So now we're just going to have to take these two away from 1, and that will give me the area of the middle part. So let's have a look. So times that by 2, taken away from 1, 0.7888. 0.7888. 0.7888 is my answer for point 2, part 2. Okay then, for part B, it's saying find W such that 1006 take away W, X in the middle, W on here is 0.9426. So we need, this is part B, we need to visualize this to start off with. So here we go, here's our drawing. 503, we have W over here, and then we've got 1006 minus W over here. And we know that the area in the middle we want is 0.9426. Okay, so if I cut this area in half, it would tell me what the area is of just this part here. And so let's do that. 0.9426 divided by 2 is 0.4713. So 0.4713 is just this part here. Okay, and I know that up to here it's 0.5, yeah, because this is the halfway mark. So this, all of this is 0.9713. So all of this area is 0.9713 for the whole area. So therefore I can now work out W minus 503 divided by 1.6, that's Z equals, but I know that it's going to equal 0.9713. So I need to go to my statistics books, 0.9713, 0.9713, and here is a value of 1.9. Okay, 1.9. So I know that my Z value here is 1.9. Okay, so this equals 1.9. So now I can find out what W is. Okay, so here we go. 1.9 times 1.6 plus 503 gives me 506.04. So that's 506.04. And so now I'm going to take away take away 503 gives me 3.04. So now if I do 503 take away 3.04, 503 take away 3.04, that should give me the value here. Hang on one sec. Okay, crazy moment there, because they only want us to tell them the value of W. So just find the value of W. So W equals 506.04 or 506. Okay, that's W. That's 8 marks so far, and gosh, we've got 7 marks for this final part of the question, so I can only imagine it's going to be quite tough. Here we go, let's have a little look. For adjustments to machine, the volume of water delivered by the machine to a bottle is such that, alright, so we've got rid of the standard deviation. So now we're looking at a mean of 503 and standard deviation of Q. And so given that the probability of x less than r is 0.01 and x greater than r plus 6 is 0.05, find the value of r and the value of q. Okay, so looking at this, we need to draw 2 diagrams, okay? In actual fact, I've got space to do it here, so I'll do it here. So we've got, going on here, the first one, we have, you know that's 503, and we want the probability that x is smaller than r is 0.01. So we want it down here. So we want this area here be 0.01, okay, and this is the value of r here. So if we go to our tables, and at the back of the tables we've got these probability things going on here. Hang on. So I'm afraid that my tables I probably need to change. So we're looking at 0.01, so 0.01, that's 2.3263. 2.3263. So we write that here, and it's a minus because it's flipped over this side, minus 2.3263. Okay. And just to recap, because it's over this side, we need, because normally it would be the value up here, and we need to flip it over and make it negative. So now let's write down Z equals R minus 503 divided by Q. We don't know what that is yet, but we do know what Z is, so we can replace the Z. Let's get rid of that and put this equals minus 2.3263. Let's tidy this up a little bit. So we've got R minus 503 equals minus 2.3263 Q. Alright, that's one equation. Now let's move on to the next one. So we need to draw another diagram. Okay, and this time we're looking at probability of x is greater than r plus 6. So it's x is greater than r plus 6. So now it's going to be over on this side then. So here we've got 503, and I'm going to put here r plus 6, and we're going over this side here, so greater than, and it says it's 0.05. Okay, so that's the area, 0.05. Go to our tables again. 0.05 is this one here, so that's 1.6449. Okay, that one there. 1.6449. 1.6449, so that goes here, 1.6449, that's our Z value. Right, so here we go with our equation then. R plus 6 minus the mean, which is 503, divided by the standard deviation, which is Q at the moment, equals 1.6449. So let's simplify this a bit then. So we're going to have R plus 6 take away 503 is going to give me a minus 497 equals 1.6449 Q. Right, so now I've got two equations. Oh, you couldn't see any of that. I need to move that up. Oh dear. Okay. So we filled it out here. R plus 6. We know the area is 0.05. Looked up the value in our book, 1.6449. So then going to our equation, we've got R plus 6. Take away that. Divided by the standard deviation gives me this value from here. So simplified it up, tidied it up a bit, got the Q over here. So now I've got two simultaneous equations. I've got this one here, okay, and I've got this one here. So now we can just use those to solve. So actually for 7 marks it wasn't that tricky after all, this question. So let's do this then. Okay, so I'm going to take away the R's. Let's start with the doesn't make any difference what I put on top. R minus 503 equals minus 2.3263 Q. Then I've got R minus 497 equals 1.6449 Q. And I'm going to take these away because I want to get rid of the R's. Okay, here we go then. So negative 503 plus 497 gives me a negative 6 equals, and then I've got minus 2.3263. Take away that, so it's going to give me minus 3.9712 Q. So now I'm going to take that over there, do minus 6 divided by minus 3.9712 is going to give me, let's have a look, 6 divided by 3.9712, 1.51, blah blah blah, can't be bothered, too tired, 1.51 equals Q. And so now I know what Q is, I can now find out what the R is, because I had here R minus 503 divided by Q equaled minus 2.3263. So now I can find out what the Q is. Oh, the R is, beg your pardon. Actually, yeah. Do you know what? I'm just going to go with the R. Minus 497 equals 1.6449 times 1.51. Right, let's have a look at this. We've got 1.6449 times 1.51, and then I'm going to add the 497 equals R equals 499.48. Yeah, that's it, that's done, that's finished. And I think, is that the end of the paper? Yes, it is. Right, and so that's the end of this one here. S1 June 2016. And I hope you had lots and lots of fun. For me, frankly, I'm pretty tired now. Very tired. It's time for my dinner.